I was watching a robin in my backyard the other day, just hopping around, and I remembered this absolutely wild fact I read.
Oh, yeah?
That bird is navigating using quantum mechanics, like actually using entanglement in its eyes to see the Earth's magnetic fields.
It sounds impossible, doesn't it?
Yeah.
But biology is just full of these surprises. The robin uses something called radical pair spin chemistry to, find its way south.
Right, and it just got me thinking, if a tiny bird brain is basically a quantum computer, is it possible our brains are doing something similar? I mean, are we just biological wetware, or is our consciousness powered by this subatomic world?
That is the ultimate question. But for a long, long time, if you asked a physicist that, they would have laughed you out of the room.
Yeah.
They had a very specific objection. The brain is just too warm, wet, and noisy.
Okay, why does being warm matter? I thought quantum stuff was happening, well, everywhere.
It is, but quantum states are incredibly delicate. Usually to keep a particle in two places at once, you need a vacuum at like absolute zero. The inside of your skull is basically a tropical swamp by comparison.
So the heat and the noise should just scramble the signal instantly.
Exactly.
Yeah.
But, like you said with the robin, nature seems to have found a way. And now we have serious scientists moving this quantum mind idea from, fringe philosophy to hard science.
So who are the heavyweights here? Because it sounds like you'd need a mix of biology and physics to even begin.
You do. The main theory, it comes from Sir Roger Penrose, a Nobel Prize-winning physicist, and Stuart Hameroff, who's an anesthesiologist. They developed a theory called Orch-OR.
Orch-OR. Okay, that sounds technical. What are they suggesting?
It stands for orchestrated objective reduction. The standard view in neuroscience is that consciousness is just neurons firing.
Chemical signals jumping across gaps.
Right. But Penrose and Hameroff said, look deeper. They point to these structures inside the neurons called microtubules.
Oh, I remember those from biology class. Aren't they just the skeleton of the cell?
That's what we thought.
Yeah.
But Hameroff proposes they're actually quantum computers. He argues that inside these tiny tubes, quantum states exist in superposition. And when that superposition collapses snap, you get a distinct moment of consciousness.
So consciousness isn't a continuous stream, like a movie. It's more like a series of individual quantum sparks.
Happening about 40 times a second. And Hameroff connects this to his day job.
Anesthesia.
Exactly. He thinks anesthesia works by specifically dampening those quantum vibrations. The brain is still electrically active, the lights are on, but the quantum music stops and you fade out.
Okay, I love the theory, but I have to play the skeptic for a second. That whole warm, wet, and noisy problem is still there. Is there any real proof our brains can handle this?
This is where the new evidence gets really exciting. There's a smoking gun study that involves xenon gas.
Okay.
So xenon is an element, and you can get different isotopes of it. Now, basic chemistry says all isotopes are chemically identical because they have the same electrons.
Right, same electrons, so they should react with the body in the exact same way.
They should, but here's the kicker. They didn't. Researchers found that xenon isotopes with different nuclear spins had drastically different anesthetic potencies.
Wait, let me unpack that. The chemistry was identical. The only thing that changed was a quantum property. The spin and the brain reacted differently.
Precisely. If our brains were just chemical machines, those isotopes should have had the exact same effect.
Wow.
The fact that the brain could tell the difference suggests our consciousness is tuned in to the subatomic level.
That is wild. It implies we are engaging with the universe on a much deeper level than just chemistry.
And it might go even deeper. There's a proposal by Joachim Kepler that our neurotransmitters might actually resonate with the zero-point field.
The zero-point field, isn't that the background energy of the vacuum of space?
It is. The theory is that our brains are essentially radios, tuning into this fundamental background field of the universe to orchestrate consciousness. And before you think this is just sci-fi, Google Research has entered the chat.
Google is looking into this.
They've launched a quantum neuroscience program. They're using these advanced quantum sensors, things like nitrogen vacancy centers in diamonds, to try and actually measure these electron spin mechanisms in neural tissue. They want hard data.
That's when you know a field is getting serious, when people stop guessing and start measuring. Speaking of leveraging advanced intelligence to solve complex problems, this is probably a great time to mention our sponsor, Embersilk.
Absolutely. If you're listening to this, you're clearly curious about how intelligence works. Embersilk helps you apply that to your business. AI training, automation, software development. They're the experts in unblocking potential.
Definitely. They can help you figure out where AI agents could make the biggest impact. Check them out at embersilk.com. So back to the big picture here. If this is true, if we are quantum beings, what are the implications? Why does this matter?
Two huge reasons. First, medicine. If something like depression or psychosis is actually a disruption in quantum resonance, chemical pills might be a blunt instrument. We could see quantum-enhanced treatments that target those specific vibrations.
That would be a complete revolution for mental health.
But the philosophical shift is even bigger. Roger Penrose argues that if consciousness involves this quantum collapse, it means human understanding is non-computable.
Non-computable. Can you give me an analogy for that?
Sure. Think of the difference between a calculator and, say, a poet. A calculator runs an algorithm. Input A always leads to output B. It's deterministic. But quantum collapse has an element of true randomness, of freedom.
So we aren't just biological robots running a pre-written script.
Exactly. It implies there's something fundamentally unique about human creativity and choice that a standard computer could never fully replicate. It sort of gives us back our agency.
I love that. It suggests our minds aren't just in the universe, like objects in a box. We might be physically coupled to the fundamental fabric of space-time itself.
We're woven into the carpet, so to speak.
That is a beautiful thought to end on. You aren't just an observer, you're part of the fabric. If you enjoyed this deep dive into the quantum nature of your own mind, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.